Howdy folks, this is your video on the standard deviation formula. So I'm gonna kind of walk you through all the parts of this formula and how to use it. The good thing about this though is that most of the time on the AP test, you're not going to be asked to calculate a standard deviation just from a data set at least, just because the the formula is so long. But I want to show you how you can do that in your calculator. And like break down these different parts of this formula so that you have a better understanding of what you're actually doing when you calculate a standard deviation, and what it measures and all that fun stuff. So I took some data from this site called Rate My Professors, which is a site that you can go to and actually like read past reviews, almost like Yelp reviews of college professors. So this is something that I used all the time when I was in college so that I could pick the professors that had the highest ratings and had the best classes when I was in college. If there were multiple sections of a class I had to take that had different professors, right? So I'm going to show you two different professors, a random sample of 10 final grades that were selected from each one. Okay, notice that they have the same mean, the same median, and the same mode. So same average, same middle score, right? Same median and same mode, meaning the score that was the most common. Okay, but obviously the data points are very, very different, right? For Professor A, you have a much smaller range that you're dealing with, right? And it doesn't look like you can get over a 77, right? And in Professor B's class, you have a much wider range, but obviously you had some people that failed, but others that got up to, 100%, right, in the A's, right? So because these two groups have the same mean, median, and mode, we need something else in order to analyze this data and to talk about spread. So the type of spread that you all are used to talking about is range, or you just learned interquartile range, IQR, which is the third quartile minus the first quartile. So it's like the middle 50%. Okay. But when you have data like this, you can also calculate something called the standard deviation. Okay. This lovely formula that you see on the screen is the standard deviation. It's a very long formula. Okay. And it has a lot going on in it. But what the standard deviation essentially is it's the average distance from the mean. Okay. So it's telling you on average how far each data point might be from the average, the mean that you've calculated, right? Some data points will be farther away than others, but we're saying if you take all of the distances together and average them, this standard deviation is the average distance from the mean, right? So a large standard deviation means that you have a much more variability in your data. A small standard deviation means you have a smaller amount of variability. Okay, so this is the formula. It has lots of parts. I'm going to walk you through each part, right, and kind of what they are, why they're included, how the formula works, all that fun stuff. Okay, so if you want to follow along with me on a calculator, like if you have your TI Inspire calculator, you can follow along with me. But I'm also going to talk you through everything as well. Okay, so if you want to do this with me on a calculator, these are the instructions to add the data into your calculator. So I would pause the video right here to get the instructions and load the data in. But if not, we're just going to kind of keep going. What you are entering right here is individual data points, which is xi. Like this, right? It's circled in red. It's this right here. So that's what you're entering. Okay, right? Then, okay, if you want to do this on your calculator with me, right, you can subtract the mean, which was 71.5, which is what's happening in this red circle right here. Okay, you have each individual data point minus the mean, right? So remember, we're finding the difference, right? The average distance, or the average distance between each data point and the mean. So in order to do that, you have to do some subtraction, right? So pause the video here if you're following along on the calculator. But again, you don't have to. I'm going to work the whole thing out for you here. Okay, so here in this second column is a list of all of the differences, right? So obviously some are negative because the data point is less than the mean, and some are positive because the data point is greater than the mean, okay? Right? What these are called is the deviation scores, okay? That's what they're called. This is not something you will ever be asked about, but I just wanted to tell you that's what it's actually called, okay? They tell us how far each number is from the mean, right? So it's the distance from the data point to the mean, right? And negatives, again, just indicate that it's going in the opposite direction, okay? Right? That's the goal, right? That's what we want. We want the average distance from the mean, okay? But normally when you find an average, right, the way you would do that is you would add all of the data points together and then divide by the number of data points you have, which is 10. So if you do that, right, and you actually add all of those things, what happens is you end up getting 0. If you add all of these values together, right, you take this and you add all of these together, what ends up happening is that you get a big fat 0, okay? The reason that that happens is because all of the negative values cancel out all the positive values. I don't know if that's actually how you spell canceled. Probably not, but this is why I teach math and not English. Okay, so all of these negative values cancel out the positive values, which makes sense, right? If you think about it, because remember, we're finding the distance from the mean, the average distance from the mean. If you have some that are positive and some that are negative, eventually they're going to end up canceling each other out. So you end up with 0 here, which is not what we want, right? Because obviously the standard deviation is not 0. All of the data points are not the same, right? That would be a standard deviation of 0 if you had all of the data points were the same. Not the case, right? So we have to get rid of these negative signs. So in order to do that, we're going to square all of the distances. Okay, and this is what that looks like. That will get rid of all of the negative signs here. So you're actually finding a distance, okay? So what we're looking at right now is just this part in red, where we took the individual data points, subtracted the mean, and then squared them, okay? Remember, now we're gonna actually get into the average part of this, okay? That's what this little summation symbol is right here, okay? This guy right here, this kind of fancy looking E. It's called a sigma. That's what the Greek symbol is. It's the Greek symbol sigma, which means to add, right? So you're basically, essentially what you're doing is you're taking this column, right? And you're adding all of those values together and you're going to get a number, okay? And so if you're doing this on the calculator, there's some instructions for you here. You can pause the video and do that, or you can continue watching and see what happens. Okay. Right? So when we add all of these up, what we get is this number, 204.5. Okay. So that's what you're doing when you calculate an average, right? You're adding all of the values together. So we're adding the distances together, and then we have to divide by the number of distances we have. So normally we would divide by 10 because there's 10 distances here. But in the standard deviation formula, we divide by n minus 1. Okay. So the question is, why? Why do we do that? Okay. Essentially, you're doing that to give yourself a little bit of wiggle room. Okay. Because most of these standard deviations come from samples, right? So when you divide by a smaller number, right? That's what we're doing. Instead of dividing by 10, we're dividing by 9 in this case, right? Which is a smaller number. When you divide something by a smaller number, then your answer, your dividend, is a larger number, right? You end up with a bigger number, right? So we're essentially just trying to give ourselves a little bit of wiggle room and giving ourselves a little bit more variability, just to be safe, essentially, right? Statistics is sometimes not an exact science, right? So what statisticians have found over many years of doing statistics is that our answers and our calculating of probabilities and all of that fun stuff is a lot more accurate when we give ourselves just a little bit of wiggle room. It's not going to change the standard deviation that much, dividing by n minus 1 versus dividing by n. It's really not going to change it that much to the point where it becomes like a problem. Okay, so that's why we do that. Just giving ourselves a little bit of wiggle room here. Okay, so when we do that, 204.5 divided by 9, we get 22.722. So right now, what we have is everything underneath the square root. But right now, we are in the wrong unit because we squared everything. In order to get rid of all these negative signs here, we had to square everything. So in order to go backwards and cancel that out, we have to take the square root. Okay, so when you do, you get 4.767. So that is the standard deviation of this data set. Okay, that's the standard deviation of this data set. Right, so what this means is that the average, on average, right, the average distance between each of these data points and the mean is 4.77 test score points or grade point percentages, right? Because that was the context of this problem, okay? And so that's standard deviation. Again, you don't have to often calculate this by hand, okay? Most of the time, this information will be given to you, and you don't have to calculate it. Okay, one other thing I want to point out to you is that this number, before you take the square root, is called variance. Okay, it's literally represented either with, for samples, it's S squared, meaning standard deviation squared. For populations, it's this theta, this symbol here for standard deviation squared. So if you're asked about variance, you're talking about the standard deviation squared. Okay, right, so give me a sec. I have to pause this so I can clear my screen, and then I'll see you back here in just a moment. Okay, so we went through that whole thing, right? And you're probably thinking, if I'm asked to calculate a standard deviation from just a raw data set, like the one that I gave you at the start of this video, you might be like, that's going to take me forever. I don't want to have to do that. Okay, the great thing is that your calculator will do this for you. Okay, and the thing that you want to look for is this thing called one variable statistics. Okay, so there's some instructions here on the screen that it'll tell you how to go through and actually do that. Okay, but essentially you're going back to your original list of data, press the menu button, look for statistics, click stat calculations, and then one variable statistics. And then you want to make sure you select the right column, right? I gave it a name. I called it Prof A for Professor A. It's a good idea if you're entering data into a calculator to give it a name. It will make it a lot easier for you to know which column you want to pull data from, okay? And when you do that, right, and you run this whole thing, oops, let me clear that off. Okay, if you go through and you run this whole thing, this is what you get. There's a bunch of stuff, but then you have to scroll down a little bit and you'll see the standard deviation here. Okay, so you may be asking yourself, okay, why are there two of them? Okay, you have SX and sigma X, right? And you get different values here, right? The one that you want for now is this one, SX, right? Because this is a sample, okay? So this one right here with the theta is the population standard deviation instead of the sample standard deviation, right? For us, for the most part, we're going to be using SX because that's the sample standard deviation. Almost all the time, we are going to be looking at samples rather than like census data, for example, that would be our entire population. okay? It's calculated the same way. It's just if you're taking everything from the population, then you don't have to divide by n minus 1. Like, you don't have to give yourself that wiggle room because you're taking the average of all of the data, right? That wiggle room is there to take into account for samples any possible variability that might show up if you pulled, say, a different 10 numbers, a different sample of 10, okay? It kind of accounts for like and counteracts essentially the natural variability of sampling and the natural variability of the universe, okay? So we are going to use SX, which is the sample information, the sample standard deviation, right? Because in statistics, we mostly are dealing with samples, right? That theta there is for the population, which is a parameter, right? There's a reason this class is called statistics and not parameters. Parameters are very, very difficult to calculate because you have to get data from the entire population, right? So again, it's going back to that idea of what statistics is all about. That statistics is about a search for the truth, right? But a realistic search for the truth, in that we can actually take data, right? Not have to pull information from everyone or every member of the population, but take a sample, right? And if we use correct statistical methods, then we can take the information from that sample and extrapolate it and make inferences about the whole population based on that. Okay. All right, so one other thing I want to make sure that you know if you're doing this on your TI Inspire calculator is if you continue to scroll when you do your one variable statistics, scroll, 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 you can see the 5-number summary, okay? Obviously, the pictures on my screen are just a random data set that I pulled and ran one variable statistics on, but you can see your 5-number summary, the minimum, quartile 1, the median, oops. So the minimum, quartile 1, the median, quartile 3, and the maximum, which is all you would need in order to create a box plot, right? Pretty cool, okay? Pretty cool. Okay, so here, if we're talking about standard deviation, we would definitely expect the standard deviation of this professor, Professor B, to be larger just in looking at the large variability in the actual data set, right? So that may give you a better idea if you were choosing which professor you wanted, that it'll give you an exact like numerical value for how much variability there is, and then give you a chance to make a choice based on how much really you want to gamble with your score. All right, y'all. So that is it for standard deviation. I hope that kind of going through that made a little bit more sense out of that really long and complicated formula. Like I said, you'll rarely ever have to actually physically calculate it. What you do need to know, okay, what's very, very important for you to know is the interpretation of standard deviation, right? As the average distance or the average difference of each data point from the average or the mean value of the data set. All right, so I will see you all in the next video, which I believe is some sample FRQs. So I'll see you then. Bye, everybody.